Welcome to this pre-class video on fatty acids. Well, we've talked a lot about carboxylic acids, and we know they are RC double bond OOH. But if you keep making these sufficiently large, where the R group gets fairly big, then you can have what we call a fatty acid. And fatty acids can have up to approximately 22 carbons. And fatty acids are going to make other important, what we're going to call lipid molecules, like triacylglycerols. Well, let's dig a little deeper into what is some of the important features of fatty acids. So let's just start again with this kind of basic formula, RC double bond OOH. And what we know, if assuming we have a fatty acid now, where the R group is fairly large, and this R is going to be a hydrocarbon, we got a fatty acid. If R has no carbon-carbon double bonds, then the fatty acid is said to be saturated. And of course, I think you've all heard the term saturated fat. Well, that's going to really pertain to triglycerides or triacylglycerols, but they're made of fatty acids. So that's going to be a very important thing we're going to discuss later on. If there is at least one carbon-carbon double bond, the fatty acid is said to be unsaturated. Okay? And actually, this kind of brings up two important terms I'm going to use over and over again. MUFA, which is a monounsaturated fatty acid. There is just one carbon-carbon double bond, and a PUFA, where there are two or more carbon-carbon double bonds. So MUFA and PUFA. And again, the properties of fatty acids depend upon the number of carbon-carbon double bonds in the R group. Now, there's another important feature about fatty acids. Ones that are naturally occurring, the carbon-carbon double bonds are cis, and we have talked about cis and trans isomers around carbon-carbon double bonds before. So naturally occurring fatty acids in animals are cis. Now we're going to talk about trans fatty acids at some point, but they're basically brought about mainly through what we call the hydrogenation of fatty acids, but that's later. Naturally occurring fats also have naturally occurring fats in animals have an even number of carbons. So again, these are just some details that we need to know about fatty acids. Well, let's actually look at a structure of a fatty acid. You can look at it and say, hey, that's a carboxylic acid. That's RC double bond OOH. That's true, but the R group is fairly large, and it has met the condition of being what we call a fatty acid. Now, every fatty acid has what we call the code. C-O-D-E, the code. You've got to know the code. You've got to be able, if given a structure of a fatty acid, you've got to be able to write the code. So let's analyze this one. First of all, we know it's a MUFA. It's a monounsaturated fatty acid, and I have been, I'm taking pride in my work. I've drawn it correctly because I know this is a cis double bond, which is naturally occurring in animals. Now, if we're going to write the code for this, we've got to be able to number the chain. So when you do a regular numbering of the chain, just like you would a carboxylic acid, you need to make the carbonyl carbon number 1. So I'm just going to number. And again, we're using kind of the skeletal structure here. I'm numbering the carbons. And there are 12 carbons. Now that makes me feel good because this is a naturally occurring fatty acid in animals. And so the code, basically, you give the number of carbons, which is 12, colon, the number of double bonds, which would be, in this case, 1. And if you've got a double bond, you've got to write the code such that we know where the double bond starts in relation to the carbonyl group. So, comma, delta just means element of unsaturation, which really just means, hey, double bond, we put a 9. So this is the code for this particular fatty acid. It's a MUFA, it's 12:1 delta 9. If I give you the code, you can draw the fatty acid. If I give you the structure of the fatty acids, you can write the code. Well, we're also going to learn in class that there's some special nomenclature associated with fatty acids. So this carbon here is said to be the omega carbon. It's at the end, okay? And you can do what we call omega numbering. This is number 1 in the omega numbering. This is carbon 2 in the omega numbering, and this is carbon 3 in the omega numbering. So this would be called an omega 3 fatty acid. And you've probably heard of these in terms of reported health benefits of omega 3 fatty acids or omega 3 fats. Another way to write this would be N minus 3. So again, this omega numbering is a special way to number a fatty acid. You start from what you would call the N carbon, the highest numbered carbon from the traditional numbering, and number forward. And so you've got the double bond starting at carbon 3 in terms of the omega numbering. So it's an omega 3 fatty acid. So this gives us a good start to what we're going to talk about in class in terms of fatty acids and some of their properties. Hope this video was useful.